Transformation doesn't announce itself, it builds quietly. One cable, one rack, one bed at a time. In 2015, Sify made a decision to back a global hyperscaler that wanted to build in India before it was fashionable to do so. No fanfare, just focus. And that quiet conviction, it's now shaping the infrastructure backbone of India's AI future. Today, banks are behaving like tech firms. Governments want hyperscaler capacity. AI first enterprises, on the other hand, are asking for GPU clouds and sub-millisecond latency. And Sify, built on a decade of lessons, missteps, and milestones, is evolving again, from legacy to leap. And today we have with us Sharad Agarwal, CEO of Infinit Spaces Limited, to discuss all of this and much more. Welcome to the third episode of InfinitLoop, the Sify podcast series. And today I have with us Sharad Agarwal, CEO Infinit Spaces Limited, to talk about all of this and much more. Welcome to the show, sir.
Thank you, Tanisha.
How is the day going by, sir? How has Delhi treated you so far?
Glad to be here. Delhi is always Dilwale.
Yeah.
So we are having fun with Dilwales here.
Sure,
so
sir.
It's always good.
So, sir, my first question to you for this podcast series is that before I actually delve into, asking about infrastructure bit, I wanted to, focus on the mindset bit for Sify. How do you see has Sify transitioned with itself with respect to mindset? I mean, when I'm trying to ask this question, my intent here is that how has Sify as a company modified itself with respect to the new age demands?
Before we talk about the new age demand, we need to think about how the data center demands evolved. Back in 2000s, when Sify launched India's first commercial data center in Vashi in Navi Mumbai, the demand for data center was that, hey, we need one managed room with the right kind of an environment where the servers should be able to operate at the maximum efficiencies. They should be able to not go down. There should be the power available. That's all. Ultimately, that's still a demand, but it was the demand that was capped at that level, where an organization says that, okay, I need to go and host a server in your premises. Bring the server, we switch it on, we'll make sure that it is available. All the time, power is available. There is no interference from the customer. There is no monitoring by the customer as long as they are able to access the servers. That was that kind of an environment. And the impact was only limited to one server, an application that is installed on the server. But now fast forward it to today, if it's not about just one server, if it's about thousands or hundreds of thousands or millions of servers that will get installed, when they will consume energy, now the impact is not on few watts. That if, let's say, a server was consuming a kilowatt and you were consuming an energy of 2 kilowatt overall, then a 2.0 kind of a power user effectiveness or efficiency, PUE, was not a huge needle mover. But when it comes to millions of the servers, when they will start using hundreds of megawatts, efficiency becomes important. What at that time you left behind as a carbon footprint on the level of renewable energy was consumed, which was not a factor. The factor was whether the power is available. But now it is about whether you are leaving less and less carbon footprint behind, whether you are making it more sustainable infrastructure. You are creating the efficient systems or designing the systems in the ways that it is more and more efficient and therefore consuming less and less resources. Now, if that becomes a factor, then it's a different kind of a mindset required to solve this. So it is a journey from just making something available to making it available in the ways that it is efficient, it is sustainable, it is having an impact on the business and the outcomes. It is not just about keeping your systems or your data center live, but also about making sure that your customer system, the end user, is also live. So it's a mind shift towards that. And this mind shift means that we are not just building an infrastructure for the sake of building an infrastructure. We are building it with a lot of innovations. We are building with a lot of efficiencies. We are building it with the sustainability in the mind. We are becoming a stakeholder in a customer's outcome. Now, becoming a stakeholder in customer's outcome is you trying to do something keeping in the mind what is the customer experience likely to be,
Correct.
not just to your customer experience, but the end customer's experience.
Absolutely.
So take an example that if I am hosting a bank's core banking system in our data center, that core banking system is hosting my account.
Yeah.
And if I am not able to access my net banking account because I did something wrong in my data center, then I am impacted by my own performance.
Correct.
So the thought process have to be like that. The thought process also have to be like that if a bank is keeping my data, it is safe. A fraction of a second of a downtime could create an issue in the transaction.
Absolutely, sir.
Correct? Or if I am going and accessing, watching IPL on a running train, I need to make sure that if that connection is getting, or that content is getting cached in one of my edge data centers,
Correct.
then that edge data center is always connected. It is always available. It is always performing.
Yeah.
If we are part of a country which is having a digital first approach, and there is a huge digital economy being driven, that means the infrastructure we are creating has to be sustainable and long-term enough so that it is contributing to digital economy of the country as well.
Truly, sir.
Right now, India's digital economy is approximately $0.4 trillion, roughly 11% of the overall economy. And India hosts the best digital infrastructure in the world.
Correct.
The best digital infrastructure systems, right? Digital systems. And as it is growing, that means we are contributing towards that Indian economy also, India's growth also. So the mindset is about keeping all these outcomes in the mind, keeping all those outcomes in our center of the thought process before we evolve into setting up an infrastructure and providing services to the customers. Yeah.
Sure, sir. I mean, taking a cue from your answer itself, you briefly touched upon banks. So I wanted to understand, banks and retailers these days are, behaving like hyperscalers. So how do you see this shift?
So first let's say, what is hyperscalers? Hyperscaler as a term has come because of the scale of infrastructure that is deployed or consumed by the cloud service providers.
Yeah.
The cloud service providers, especially the top four, AWS, Google, Microsoft Azure, and Oracle, and then some more like Metas and the others, they deploy large amount of infrastructure, which is then used and given to the end user as a service. And because of the huge volume, generally they end up consuming the data center infrastructure, if we just talk about the data center, in terms of the hundreds of megawatts in a region like India.
Yeah.
In other regions, they may still be consuming 20, 30, 40 megawatt of data center capacity. And as the systems are evolving, as the new usage are evolving, as the artificial intelligence coming and getting deployed, those usage are only increasing. So it's about the scale. Now, let's say if we take that as a parameter scale, that hyperscaler will consume minimum 10 to 20 megawatts of capacity in a particular cloud region. Therefore, see that, hey, are there banking systems or are there enterprises also started asking for that kind of a capacity? With the advent of digital payments and a lot of digitalization in the transaction, you would know that number of transactions that we do online has increased.
Yeah.
And somewhere I was reading that it's doubling in India almost every year. Billions of transactions happening every year and then growing in billions.
Correct.
And so many transactions do require infrastructure, compute and storage infrastructure. And the banks in India have continued to own their infrastructure. They continue to own their setup. And therefore, to take care of this scale that is coming up, they do need large data center capacity. So in recent times, the largest banks in India, top 5 largest banks of India, have started asking for the data center, or have started planning for the data center infrastructure
of their own
that could go in tens of megawatts over the period of time.
Okay.
And if you top it up with artificial intelligence based use cases that could come up over the period of time, or high compute demand use cases that come up over the period of time, and then you have those constraints where always available infrastructure should be able to scale and be ready for the demand for next 10, 20 years. Therefore, you need to have a land or building locked for that long period, because moving an infrastructure or scaling infrastructure in the other premise could still be a cost factor.
Yes, sir.
Keeping all those in the mind, they are also, and it is good news for everyone, and it's a good news for a good indicator of economic growth also, that they have started thinking in that way. So yeah, so that's how you say that the banks have also started acting like hyperscalers.
Sure, sir. I mean, now that we've spoken about banks acting as hyperscalers, I also wanted to understand specifically for hyperscalers and in fact data centers also, how do you envision them? I mean, what is it that lies for it in 2030 or maybe 2040?
So what lies in 2030 or 2040 is something that we have to think about today itself. The reason for that is the infrastructure that we are deploying today is typically an infrastructure that will get depreciated over minimum 10 years. And in other ways, it will probably work for another 15 years. So what we build today have to be still relevant in 2035. And then only the proper return on these investments would be possible. So the other way to ask this question is that how are we building our infrastructure today, which will still be relevant in 2035? How are we building infrastructure today that will be able to serve the demands of 2035? There is a lot more thought has to go on that one. The way we are thinking right now is thinking in terms of what demands have come from the cloud service providers and what demands are coming over the period of time from artificial intelligence use cases. And all these use cases right now are pointing towards more dense infrastructure. And therefore, what we need to plan for the technologies that are able to support denser and more energy dense infrastructure, more you could say the strengthened floors that can carry a lot more weight of the infrastructure, that the servers that will be coming up. It needs to make sure that it needs to count for energy availability in the future. So thinking about in terms that, hey, whether we will be able to bring the energy to the data center where we are building it, and we will be able to bring renewable energy to that location. We need to think in terms of the security, ever-evolving security situation in the world, and the surprises that we are seeing in geopolitical situations in last few months. Whether the security has been thought about to that extent. And as we move forward with the digital economy progress and the digital infrastructure becoming key to growth, it is quite possible that it will become more and more vulnerable. Therefore, the security aspects and on the safety aspects, making sure that so much of energy dense setup is still secured for people. Correct? So thinking the infrastructure in these terms. And evolving and innovating in the ways that you could cool it in a better way. You could also improve the efficiencies in the ways. And then think of also that when the data centers that we created in 2015, whether we can reuse it further or repurpose it for the newer use cases over the period of time.
Correct.
So these are the factors playing in our mind right now. But how will it involve? How the quantum compute kind of infrastructure or demand will require the data center. There will be a lot more progress happening on that we will need to keep a watch.
Sure, sir. So, being a Sifyite, I can't stop myself from asking this question though. There was this recent news of paper use. Do you want to briefly touch upon that?
So, pay-per-use is specifically targeted towards GPU as a service providers
Sure.
or the artificial intelligence-based cloud service providers. Uh, the organizations across the world, when they are investing in GPU as a service, they make significant investments in purchasing of GPUs. And at the same time, they also need to make significant investment, or they have to go and rent the data center infrastructure also. And that is a fixed cost. What we are saying is that we want to take the risk and we want to participate and or we want to share the risk with the GPU as a service providers. So while you are as a GPU as a service provider offering that service, the underlying infrastructure that we will provide, we will build that infrastructure to you when you bill your customer GPU as a service. And that offers a good flexibility to these organizations because infra is taken care of.
Yeah.
And it is a huge percentage of the overall cost. And while we become part of their risk, their outcomes, we are saying that we are in the game with you on that. This also is specifically targeted towards those organizations who across the world have deployed GPU as a service, but have not made India as their home. So this is a way to attract them to India. And therefore, it also helps a growth of AI in India.
Okay. So I was also reading about GCC offerings of Sify, and one of the offerings within GCC capacity is us talking about data centers and network. Do you also want to talk about something over there?
Yeah. The global capability centers in India have grown from old days of business process outsourcing or knowledge process outsourcing to offshore development centers, now to research and development hub, engineering hubs. Now in India, there are organizations who are doing cutting edge researches completely based out of India, thinking about next generation aviation methods or engines or next generation automobiles. And all these activities, and when they are happening, those researches with big capabilities, they require infrastructure also. The previous generation BPOs, KPOs, they were just the remote offices of global enterprises with some processing, some activities happening here. They didn't need more than a network infrastructure. They could connect to their centralized cloud infrastructure or centralized data centers to access everything. But now there is, because of the R&D setups and the heavy engineering setup, a lot of these work that are happening require low latency local infrastructure. And therefore, there is a demand for the data center. What we are saying is that we are specifically going and building the data centers in the hubs of GDC, GCCs in the country. And these happen to be a lot of them in Bangalore, Noida, and Hyderabad. And this is where we are going and launching large data centers, specifically targeting towards them. They also are doing a lot of simulations. They are doing lab testing, all of that. We are saying that we will make it customs built, custom suited for their kind of needs, and then be able to offer them something closer to their India offices, wherever this is possible. Right?
Sure. So I was recently reading an article, I'm not able to recall which newspaper exactly, wherein they said that infrastructure is also culture. So any thoughts over there?
When you say infrastructure as a culture, it really means that to what extent you are making sure that infrastructure is resilient and available. So we drive that as a culture around certain philosophies. So what is the philosophy? That let's make sure that our infrastructure has 6 zeros. right? That it is designed in a manner and it is operated in a manner that it is always available. That means zero downtime. You make it available all the time. You ensure zero downtime because you have designed resiliencies in the infrastructure. You have made sure that it is risk-free. Therefore, make sure that there is zero risk of it, zero resiliencies. If there is a failure in resiliency, then you know that you need to be at heightened operating stages
Correct.
to make sure that
Yes.
the even the primary part doesn't fail.
Yeah.
So zero resiliency. Data center host critical data. Customers and all of us are fully worried about everything that we host. That means it should be fully secured. So zero security issues. There is so much of engineering components involved. There is so much of energy involved, and it's very dangerous environment in that way. So it has to be
Yeah.
zero safety issues, fully safe.
Truly.
And if you are building a data center which has any defect, then any of the other above four will not be possible. So
Yeah.
defect free, zero defect. And then making sure that over the period of time, you are designing and building an infrastructure which is leaving zero carbon footprint behind. Now, if we have to do all these six have to be the mindset. These six have to go in the ways that it is driven as a culture, not as a requirement. Actually, these 6 zeros could also become part of an SLA. But if you take it as an SLA, then your thought process and mindset is different. But if you take it as a mindset, then it's a culture. And therefore, we call it as infrastructure is also a culture, because it has to be deep enough, it has to be sensitive enough so that it is being designed and delivered in the manner that it is defect-free, always available, responsible and accountable to the energy, to the sustainability, to the Mother Earth, and safe and secure.
Absolutely. So, I mean, this conversation has been really enlightening, sir. In the interest of the time, I'll have to actually, close it here. But I do hope to hear from you soon. Thank you so much for your time.
Thank you
sir.
so much. Thank you for having me.
Thanks, sir.
Right.